today. Now see, before understanding friction properly, you have to understand the concept of frame of reference, which I have started when we had started motion in a straight line. Remember that time, what did we discuss? We had discussed that frame of reference basically means place of observation. If you are having a particular frame, right, one particular place of observation, another object can appear to be at rest or in motion to you. For example, one example that we discussed that time also, I'll mention it here also. A person is standing on ground. Fine. A person is standing on the ground. A train is moving. Two passengers are sitting in the train. Now the person who is standing on the ground, for that person, both the two persons who are moving in the train will appear in motion, right? If I'm standing on the ground and I see two people who are moving inside a train, I will say they both are in motion, right? So this is one conclusion that I have drawn, that yes, both are in motion. Now, when both the passengers are in motion, when I'm talking about both the passengers, means one passenger with respect to other. This passenger is looking at the person who is sitting in front of him inside the moving train. But for this person, the passenger in front of him will appear to be at rest. This was the same person who was appearing to be in motion for the person who was standing on ground. So is the third person at rest or in motion? There is no one definite answer which you can conclude. This depends upon place of reference. All right, class. There is no one answer that you will say that the person is in motion or is at rest. You will say person 3 is in motion with respect to person on ground. Person 3 is at rest with respect to the passenger sitting in the front, whatever is the name of the person. All right, this is how you define. Now, why are we revising this? We have already discussed this. Why are we revising this concept back in here in Newton's laws of motion? We had already discussed this. We had seen also, we studied the concept of relative velocity also. Now, why are we bringing this? So see, frame of reference basically means what? After frame of reference, inertial frame and non-inertial frame are the two frames which you have to keep in mind. Basically, inertial frames are the frames where Newton's laws are valid. All the three laws of Newton's which we have studied, three Newton's laws, no, we have studied. First one, inertia one. Second one, F is equal to dp over dt. Third one also we have discussed in the last class, action reaction forces. So all these are the inertial frames. The frame in which Newton's laws are valid. This is called inertial frame. All right, if you are having a frame that is accelerating, this means, see how to identify inertial frame and non-inertial frame. This is clear, no? Newton's laws are valid and Newton's laws are not valid. Now, how will you identify whether you can apply Newton's laws or not? Right? How can you apply Newton's laws or not? So see, suppose I am taking a system where the entire system is at rest. All right, the entire system is at rest. It means, suppose I have taken a car is moving on the ground with a particular velocity. A car is moving on the ground with a particular velocity. This I have. All right. Now, for me, the ground is appearing to be at rest, right? The ground is not moving. The floor is not moving. So frame of reference, when I'm saying the car is moving, so my place of observation is what? The place of observation becomes this part only. Car plus ground. So is the ground moving? Is the ground in uniform motion? No. The ground is static. The ground is completely static. So in such cases, what will you conclude? If the car is static, it means the frame is at rest. Frame means your surrounding. Frame means frame of reference only, place of observation only. So when we are saying place of observation, this means that you have to consider the frame of reference. All right. When I say inertial frame means the frame in which the background, the surroundings are not moving. All the questions which we have done till now, all the questions which we have solved, did we say that the background is also moving, road is also moving? No. So if you see such a case, car is moving, that motion is fine, but is the frame also moving from where you are observing? If suppose I am observing, I am also moving and I am observing a velocity of that car. So now the place of observation becomes in motion. So that time we have a special force which we call as pseudo force. Pseudo force basically gets applied at the system. This is all the formula of pseudo force is exactly the same as mass into acceleration. In any ways, pseudo force, let's not talk about right now. Now, non-inertial frame. Suppose there is a truck. All right, there's a huge truck. And on the roof of the truck, no, on the ceiling of the truck actually, with the help of thread, I have actually hung a pendulum. This is the roof of it. And here is a bulb I have connected, bob I have connected. Now, as soon as the truck will start moving, as soon as the truck will start its forward progression, what will happen? See, it will move like this. As soon as the truck will start, even when we are also sitting, we are also inclined a bit back. So when the person is, when the pendulum is connected, it will also move. So now the force that will act, and all the acceleration, all the velocities, here you will not use your Newton's laws. Why? Because now if we have taken this as our system, if this is our system and place of observation is within the truck, then for me, my frame is also accelerating. This is also moving. Earlier, only this was moving. Now this is also moving. So this is called as non-inertial. So inertial frame basically means, in simple terms to remember, you can say background remains at rest. And if the background also starts moving, starts accelerating, you will call it as non-inertial frame. You have some questions like if lift has also started moving. So lift, which was initially the place of observation, has now also started moving. So this, in this case, you will say these are all non-inertial frame. So a very basic thing, you don't need to go into the details of this so much, just remember the basic differences between them. Coming to friction. See, friction is a force that provides resistance to motion. All right. Why friction occurs in your system? Everything we'll study in friction. Friction is a type of force. It's a dissipative force. We have already studied about in work, energy, and power. Remember, we have studied conservative forces, non-conservative forces. So friction, no, it provides resistance to motion. That is fine, but it also produces heat. It wastes energy. So we call friction force as a non-conservative force firstly, and it depends upon entirely the path traveled for work to be done. All right. Now see, what is exactly friction. There are irregularities. Suppose this is a surface. This is a surface. I have zoomed in the surface. So this is how the irregularities appear. Though it appears to be smooth, this appears to look smooth when we are looking at it. But even without it, there are certain irregularities. So suppose these are the irregularities of one surface present. They are exactly at the microscopic level. Some irregularities we are able to see by ourselves, some irregularities we are not able to feel, but most of the irregularities we are able to at least identify. We can at least say this surface is smooth, this surface is rough, and there is one more surface. This surface also has the irregularity, smoothness is not there. So when two objects are kept like this, nothing happens, nothing. Okay. But as soon as they are rubbed against each other, what happens? Can you see these irregularities? These are actually rubbing against each other. These irregularities, they are rubbing against each other, right? So because when the irregularities, they get interdigited and they started rubbing each other, that leads to production of heat. And the force that opposes this, and the force that provides restriction to motion, you can see if suppose something is smooth, it will glide off easily. If something is rough, it will keep on getting interlocked. So that's why we say friction provides resistance to the motion. Friction is force is not a very difficult force to study, not a very difficult force to understand. Regarding the types of friction force, I'll do it later. First, note down some points till here. Because then I'll do all the types of friction forces together. But before that, just write down the basics, then I'll discuss. WRT means with respect to. With respect to. C class, let's now discuss the types of friction. See, when we are discussing the types of friction force, you have to understand the fact that there is external force also occurring in the system and friction force is also occurring in the system. See, those who haven't written, I'll give you time. Just let me know. Okay, see, there are three types of friction: static friction, limiting friction, and kinetic friction. You can study static and limiting together. Kinetic is a little different, but static and limiting, they are just very, very similar. There's a very slight difference with each other. Look here at an example. Suppose this is a box that is kept. Some mass of this box is present, right? Now, I have applied a force, let's say 5 Newton. The box is kept and I have applied a force 5 Newton. I'm noticing nothing is occurring. So it means there is no friction force in our system. Resistance is occurring. There is resistance to the force. So frictional force is there. But nothing occurred. It was heavier. Maybe I have not given enough force. Suppose this is it. This is it. I have applied 5 Newton. Nothing is occurring. So when nothing is occurring, it means the frictional force that is acting is called the static friction. All right. Static friction acts in the system where it occurs in response to the external force. It occurs in response to the external force, but there is no net movement. Everything remains static, stationary. The object remains static. The object remains stationary. That's why we call it as static friction. All right. Suppose I have increased the force. I have increased it to 6 Newton. Now I am noticing still the object is not moving. It means the value of static friction has also increased up to 6 Newton. Value of static friction. Static friction is also called self-adjusting friction because according to the values, according to the forces that you are applying, according to the external forces, it also changes its value. 5 Newton, so 5 Newton ho gaya. When we applied a force 6 Newton, it became 6 Newton. All right, this is how static friction works. All right, then what happens? Again, I have applied a force 7 Newton. I am noticing nothing has occurred. This is still 7 Newton. So again, static friction is what? It's the limiting friction. Limiting as in not that limiting friction, limiting in the movement. Static friction doesn't allow the object to move, but it keeps on occurring and it increases with the force. Suppose I have to push this laptop. So if I push it with a little very less force, the laptop won't move, right? I have to apply a certain move to push this laptop, right? So when I'm seeing a small force is being applied, in that case also you have frictional force that are existing. All right, frictional forces are present which are existing. Those are called static because no movement is occurring in your system. Now I have noticed as soon as I have increased my force to 8 Newton when I was pushing it, this frictional force, this was still 7 Newton only. It couldn't be increased. This value couldn't be increased further. So this frictional force now that is acting in our system, now the object has moved. You can see the left hand side term is lesser than the right hand side. If I'm applying a force more towards the right, it will move towards the right. If more force is applied towards the left, it will move towards the left. But right now, more force is being applied towards the right. So this also moves towards the right. Okay. So now understand what are all the types of friction. When I applied these forces, 5 Newton, 6 Newton, here static friction was keep on continuously adjusting by itself. And it didn't allow the body to move. Then I had received the maximum value of static friction. There was a maximum value beyond, you can see, with which it couldn't adjust itself, right? There is a maximum value of every static friction, beyond which it cannot work. Otherwise, every object you will be able to, you'll never be able to move any object. Friction will never allow. But since the static friction value has a certain value, maximum value, beyond which it doesn't allow any motion. So this maximum value, 7 Newton, which I can see, this is the maximum value when both of them are equal and no motion is occurring. That is called as the limiting friction. This is called as the limiting friction. Maximum value of static friction. Still, the body hasn't moved, but this is the maximum value. Beyond this, the body will. And once the body has started motion, now the friction force that will come into your system is called as the kinetic friction. So static friction, self-adjusting friction, it doesn't allow the object to move. Limiting friction, maximum value of the static friction. Maximum value of static friction is called limiting friction. All right. And it also doesn't allow the objects to. And finally, you have kinetic friction, which allows objects to move. This is what is meant by all the three types. Now, what is static friction? It's the friction that acts on the body at rest. This is important, at rest. Actual motion has not started, and this is self-adjusting. When we use the term self-adjusting means, you could see if its maximum value is not reached, it will keep on increasing its value. Beyond this, it will not increase. Then limiting friction is the maximum value of static friction. And what is kinetic friction? It acts when the body is actually sliding over another body. Motion occurred when the kinetic friction came into the system. It is always less than limiting friction. Why less than limiting friction? Because see, actually, no, in this example also, this value will be somewhat less than 7, a little less than 7, like 6.9 Newton, 6.8 Newton, like this. This will be a little. Why? Because once the motion has occurred, the resistance is less. When the object was rigidly kept, friction was also more to not allow the object to move. When the motion is there, when the forces have been overcome, right? So friction value also decreases because there is nothing to oppose. One graph that you have to remember, and it's a very important graph. This is there in your textbook also. This graph comes as a separate question also to draw. And I will suggest if there's a theoretical question in your exam to write about the types of friction, do draw this graph by yourself. This basically says that, see, frictional force versus applied force. Both are increasing. You have increased the frictional applied force, frictional force increased. Again, you increase the applied force, frictional force increased. A maximum value was achieved, which couldn't be increased further. And finally, it reached a plateau, saturation point. So this was static friction, maximum value, limiting friction, and finally in motion, kinetic friction. All right. And causes of friction also I have discussed with you. Causes of friction, intermolecular forces between two surfaces. See, if we go into the details, no, if we see the structure in detail microscopically, then you will see irregularities are present between two objects like this. Even one more thing occurs that is helpful for your class 12 more, not so much for class 11. There are charges that are present over here. So these charges are also moved. Electron transfers also occur. Electrons also move up and down because of friction. Friction, the work done to overcome friction helps in facilitation of, it facilitates electron from one object to other. That is also possible. All right. Basically, it's the irregularities. They become interlocked to each other. All right. And when they are moved, see, when they are continuously locked like this. Right? They are locked like this. But when they move, these irregularities, they rub against each other. And that leads to production of heat as well. Best example, take your palms. These are rough surfaces, right? This is not smooth. You have creases on your hand, right? Shape is also not fixed. Somewhere it is in depth, somewhere it is exactly superficial, right? Now you start rubbing your hands. After a while, you will see hands become warm. This is because of friction, because it's a dissipative force. Friction force, we also call it as a necessary evil, because firstly, it's a dissipative force in your system. It's a non-conservative force. So that's why we call it as an evil. But you also know the importance of friction force. Without friction force, objects will not be able to stop. All right. Friction force provides resistance and ultimately it stops. Otherwise, if friction force is not present in your system, inertia won't be able to overcome. If a body is in the state of rest, it will be in the state of rest until and unless you do not have kinetic friction in your system. Kinetic friction help in the movement, right? Or you can say if something is in motion, you have rolled a ball on the ground. After covering a certain distance, the ball stops by itself. It's actually the friction that has come into action. All right, kinetic friction has stopped it. So like this, friction is also often called as a necessary evil. So this you can check in your books, textbook, just check it once, necessary evil point. Some points are given, pros and cons of friction. That can also be helpful to you. All right. Okay, start noting from here. Some students didn't write it from here, friction. This. See, coming to the laws of friction. When we talk about talking about any law of friction, this is not just valid for limiting, but limiting we are taking because this is in between static and kinetic. See, normal reaction we have talked about. What is normal reaction? Wherever two objects are in contact with each other, normal reaction is basically a contact force that acts away from the body, right? So if the block is kept, if this block is kept, then normal reaction will occur above, like this. And gravitational force will always act downwards, right? And other forces will also act. Friction force will act here. Now we are aware of friction force, so we know friction force will also act, and external force, applied force will also act, and so many forces. What you have to remember is that frictional force depends upon normal reaction. This is the formula which you have to remember. Do not remember the formulas for normal reaction. Normal reaction for every question, it will vary. Normal reaction will vary for every question. For example, if I tell you this, one more thing, let me add it here. Frictional force is directly proportional to normal reaction. So when you remove the proportionality constant, you get a constant which we call as mu, which is coefficient of friction. Now, many students do what? Most of the times, normal reaction becomes equal to the weight, right? N becomes equal to mg. So they learn the formula as F is equal to mu mg. No, this is wrong. This is not the formula mu mg. Whatever be the value of N, it will change accordingly. See, suppose I have given you, this is a wall, this is the block. Here normal reaction is occurring, here some force is being applied, here mg gravitational force is occurring. Can you see now this normal reaction is not equal to mg now? Mg is acting downwards, whereas normal reaction is acting on the different axis, on a different axis, x-axis. So here this will be equal to something else, this force or whatever we'll calculate according to the situation. So do not learn this, because most of the students remember it as F is formula of friction as F is equal to mu mg. No, formula of friction is mu n. Now depending upon the value of n, you can substitute in the value of friction. Okay. So yes, friction depends on normal reaction. It is independent of area of contact. Means for even a heavier object or a smaller object, friction will depend upon the irregularities. Friction is concerned with the irregularities. Okay. So whatever is the size, all the irregularities make up the frictional force. And it increases with roughness, because as the irregularities will increase, interlocking will increase, that will result in greater friction. Okay. So this we call as the laws of friction. So when we are talking about limiting friction, yes, this I was telling you. Now properly, let's see. If this is mg, see, frictional force is directly proportional to normal reaction. Frictional force is mu n. This is the formula which you have to remember. What is mu m? What is mu s? See, mu L I am writing, that is coefficient of limiting friction. Coefficient of limiting friction. This is the coefficient of limiting friction. Similarly, if it's a static friction that is occurring, so you will have F S is equal to mu Sn. Both are same, both are basically the coefficients. Now, depending upon the values of n, you will get different values. For example, look at this question. This is normal reaction will occur upwards, mass into gravity, acceleration due to gravity will act downward, and static friction's coefficient is given. So F is equal to mu n. Now see, further we can see that n is equal to mg. That's why I can say F is equal to mg. This is just valid for this question. This is not a standardized formula. So mu is 0.3, mass is 10, acceleration due to gravity, I'm taking it as 10. Since nothing is mentioned, you should in your exams take it as 9.8. Fine. So this becomes 30 Newton. 30 Newton is the frictional force that will act. That is actually acting to make the body remain at static position. Rest of the questions we'll discuss. First, you note down the laws of limiting friction. These are important, class. Laws of limiting friction, laws are important. These come separately to write. Note it down. C class, one more question let us discuss. Then some portions are left that we'll do in the next class. Then tomorrow you have your class. It says a body of 20 gram is placed on a rough surface having 0.3. Calculate force of maximum static friction. So basically you have a body whose...
Teacher,
Yes.
uh, I'm supposed to be attending a math class right now, and from the web I joined this class. I think I got the wrong
Yes,
link.
you just check the ID. This is actually physics class of 11th. Okay. Please just check the link once again.
I need to join. Yeah, I joined from the link thrice, and I kept joining the same class.
Same class. What is the timing of your class?
My class is 5 o'clock. I'm in ninth, and I'm supposed to be attending a math class.
So there are 15 minutes left, no?
I'm supposed to be attending at 5, and it's 5:13.
You were supposed to be attending it at 5. Let me know. Just to give me a minute. I'll just let you know.
Yes,
Okay, what's your name?
Simrat.
Simrat. Simrat, I think one more link has been shared with you. Just check once again.
Okay, teacher. Thank you.
All right. Yes, we were discussing. So 20 gram is there. So again, normal reaction will occur and here mg will occur. So coefficient of static friction is 0.3 over here. So when we have to calculate friction force, this is also easy, mu n. And since we know n is equal to mg, so this also becomes equal to mg. Friction force is 0.3 into 20 into 10 to the power minus 3 into 10. This much Newton it is coming. So 6 point something, this will be your answer. Let me know what's your exact answer. Note it down.
Ma'am, how did you get 10 raised to minus 3?
See, it's given 20 grams. Okay, we want our SI unit. So I've converted 20 grams into kgs. This is in kgs. Fine?
Okay, ma'am.
Rest of the part, it's lengthy. We have to see some other questions are also there. And kinetic friction we have to start. So all those who have completed, you people can start leaving. Tomorrow we'll continue friction from here, kinetic friction. Okay, class. Thank you so much.